Hey, well, good morning there, pre-algebra. I am glad that you are able to tune in today. We are here, and we are going to be talking about a somewhat new topic, and we're going to be kind of identifying graphs, equations, and tables, and we're going to be figuring out, are they linear or nonlinear? But before we begin, here is our joke today. What kind of flower is on your face? I'll say it again. What kind of flower is on your face? Tulips. There it is. All right, you're going to definitely want to be on page 520. I tried to do the graphs as best as I could on the smartboard today, but it's really going to be helpful for you to follow along. So let's cut right to it. When something is linear, not linear, linear, I'm sure math people are really pulling their hair out. Linear, it is pretty much asking, is it a straight line? So we're going to identify 4 different charts. When we're talking about identifying by looking at a graph, that's simply all it is. Is our line, is it straight? Is it 180 degrees? It doesn't move. It's constant. That's what it's asking. So when we look at A, again, mine is not so good, but there's some little bends here. Is that a linear line? No, it is not. It is not. So it says the graph is a curve, not a straight line. So it represents a nonlinear function. Remember, function just simply means an equation. So this one, it says, is y equals negative 2x cubed. That's what that equation or that graph represents. Now let's look at B. Is this linear? Yes. It has a constant slope. It doesn't change. The slope does not change, so that makes it linear. We would write this one as a y equals mx plus b. Somewhere it's, our y-intercept is a positive number. So that's how we would represent a linear function. C, not linear. And you all should know that because my smartboard's freaking out because it's curved. Our slope is not constant. And that one is when we have any kind of squared number. All right, last one, also not linear because it is also curved. So remember, a linear function has a constant slope. Nonlinear has curves and bends and an irregular slope. Okay, let's turn the page and identify whether things are linear or not linear by looking at an equation. So the big determinant is, can we create, if it's linear, can we turn the equation into y equals mx plus b? That's the big thing. If we can turn an equation to this, then it would be linear. So looking at this one, we're going to call this one A, or in your book it is also called A, and this one's B. So looking at 3x plus y equals 7, can we turn it into a y equals mx plus b? Definitely. We subtract 3x from each side, and we get y equals 7 minus 3x, or negative 3x plus 7. Alright, so this would be linear. Next, here, can we turn this into a y equals mx plus b? No, we got this funky looking exponent here. Whenever we have an exponent, or maybe you'll see, something like that, which means a negative exponent, this is nonlinear. So we're going to put an x, but I want you to write nonlinear. But just for the sake of time, so just, you see the square, you can't turn it into y equals mx plus b. See, this x only has an exponent of 1. It's invisible. It kind of likes it that way. So we cannot we cannot put a function here. We can't. It's a nonlinear function. All right, so let's identify right here. Y equals 1/5 x. Sure, this is linear. We could say it's plus 0, where we get the plus b. But the big thing is that our x does not have an exponent, so that would be linear. Looking at this problem, we have an x as an exponent, so that's going to be funky looking. So this would also be nonlinear because it cannot be written as y equals mx plus b. That's the big determinant. Okay, because for example, if I were going to write y equals, there are multiple things that we can put in for x, so our graph is going to look really crazy. Actually, I don't know what it would look like on a graphing calculator, but that's something you'll get to in the future when we get to actual algebra and graphing these funky looking equations on a calculator. They look pretty cool. Okay, now this is what really makes sense for me when we talk about linear is remember how I'm saying constant slope, constant rate of change? This is what our tables show us, and this makes it absolutely clear for me. So I'm going to label this function is linear, not only because we determined that we can turn it into y equals mx plus b, but if you look at our changes right along this side, they're the same. They're constant. They don't change. If I were going to write 5, the answer is going to be -8 because I know it's going to constantly decrease by 3. Or it's going to go down by -3, our y-intercept. So it's changing constantly. This would kind of be like our slope. It's always going to go down -3. It's not going to change. We can trust in it. Alright, however, if we look at this equation, we are changing. We're changed by +6, then we went +10, then we went to +14. It's going to keep increasing, and it's not constant. So that's what makes this nonlinear. I hope that makes sense for you. It does for me. Again, if you struggle with the idea, don't fret. Let me know. We can work through this. Math is not going to ruin your day, I promise. Alright, so let's look at some examples here. This is our last one. We have B right in your book, so this is at the bottom of page 521, and you are going to be identifying what are the rates of change and is it linear or nonlinear. So this is the example. We're increasing by +1 each time, linear or nonlinear. This would be linear. These are the same, it's constant. So let's take a look over here. So as our x's increase by 1, our y's, we go from -5 to -20, which would be an increase of a decrease of 15, so we have -15. When I look at this one, 20 to 45, now I'm at -25. And here, 45 to 80, that would be -35. So we are not constantly decreasing. We're actually it's an exponent. You can tell that we're changing. These are changing by 10 each time. So that's kind of interesting. But that'll help us form our equation. But these numbers, these first ones, this is what we're really looking at. They're not constant, they're changing. So this would be nonlinear. So just an overview, we've determined if functions are linear or not linear by graphs. So this is, a makeshift graph. There's our linear line. We've also determined linear and nonlinear by equations. So remember, they have to be changed to y equals mx plus b. And by tables. So remember, we're looking at these numbers on the side. Those are what's important. Okay, and you'll see that you've got a story problem, but in the interest of time, I want to cut the video short. Use your good problem-solving skills, and also you may work together on those story problems. Okay, work hard, and I'll see you in real life.